Okay, welcome back. So we have number 23 now. So it's about a sequence. So arithmetic sequence. We are given a number of terms which is larger than at least or equal to 3. And initial term is a, common difference is at least one more than 1. And the sum of those numbers are given out by 1, okay, which is 222. So based on that, what would be some of those three letters? Okay, so like before we move on, I'd like to remind the formula. So for some of us, so let's get started with that first. Okay, so like arithmetic sequence is just a sequence, you just keep adding the same number. So and then if I start with a, the next number will be a plus d. So you're adding the difference to the first number to get the second one, and then you are adding another d, which would be 2d now. And you keep doing this, right? If you have n terms, we have n terms. Since we get like second term by adding 1d, to get the third term, we add 2d's. To get the nth term, we are gonna add n minus 1d, okay? So which means the last term would be a plus n minus 1 times d. I hope that makes clear. So again, we are trying to add the d's, like common differences, to get the next term. So we start with the second term by adding the difference. So that's why for the nth term, we are gonna need to add n minus 1 d's, okay? So this is the sum. And if you do remember the formula for this, then go ahead and use that for sure. But let me just get that formula. So to do so, we are gonna rewrite these backwards. So the last term was this whole thing. Okay, so if you rewrite the you will get a plus n minus 1 d, and then you will keep getting those. At the end, you are gonna get a. So you can just complete the rest. So the previous, like the first term will be last term. This guy will be second from the last one. So a plus d, and you will continue with the other terms as well. But I'm not gonna do that for now. Okay. So if you add these, you will get 2s. And then this is my first term, and then this is the first term when you swap the order. Okay, a plus this, that will give me 2a plus n minus 1d. Okay, and then if you do the same thing with the second term, the second term right here will be a plus n minus 2d. A plus a will be 2a. D plus n minus 2d will be n minus 1d. So which means you will get the same sum. If you add the last term by the last term, you will still get the same thing. So which means this guy will be the same term when you add those corresponding terms. Since we didn't really change the number of terms when we add this backward, the number of terms in this list still n. So that means the sum of those actually gonna be n of these same terms, okay, when you combine them. So if you divide by 2 to get nice formula, it's gonna be n over 2 times 2a plus n minus 1d. Again, this is something you probably already know because this is really common stuff, but it's sometimes confusing to remember. So that's why I like you to do this approach whenever you need it. It will take a bit more seconds, but that's fine. Okay, so now we got the formula. Okay, so we can ignore this at this point. So let's take this out of the way. We are told the sum of those terms, okay, which is like n over 2 times 2a plus n minus 1 d is equal to 222 plus or minus 1, which we don't really know, is it going to be 221 or 223, right? So, but look at those two numbers. Since we have only two cases, let's think about those, 221 and 223. And if you look at these numbers, like prime factorization of these, this is actually 13 times 17, but this guy is not divisible by any prime until like 15, which means this is a prime number. So there is no like other factors other than itself and 1. So that's a prime number. So, but we cannot really have n1 because we are told that's going to be larger than at least or equal to 3. So which is why this is the only shot we have. So if I choose like n as like 13 or 26, and then this parenthesis will be 17, you can go with that. But if you do so, n will be 26, and that should be like 25 times d plus D, which doesn't make sense either because you will get larger than 17. So let's go with N as 13. If N is 13, so 2A plus 13 minus 1, which is 12, 12D is equal to 17, but this was N over 2, or this divided by 2, which will be 34. Okay, so divide by 2A plus 6D is 17. And there is not much right numbers that will satisfy. If I go with 2, that's 12, so you will get 5. If you go with 1, that's gonna be like 6 lesser will be 11. But if I go with 11, let's see if this is gonna work out, right? So when you have 11 for your first term, okay, so then you can actually take a look at right here, N over 2, 11 times this will be 22, N was 13, that will be 12 times D, but actually that doesn't work, no need to check because we are told D is larger than 1, so that means this is the only integer value is actually working, which is what we are looking. So that's why we know the N is 13, A is 5, D is 2. There is no other ways that will satisfy these conditions. So that's gonna be 7 plus 13, which is 20. So I hope that makes sense. So this was a number 23, but it's just using the common approach that we use to get the formula. After that, we just use our bit number sense. Okay, so I'll see you in the next video.